Advanced Financial Modeling, Topic 2, Portfolio Optimization. References for this material in Financial Modeling Edition 4 or later by Simon Benenga, and there's a number of chapters can help you with topics including portfolio models, calculating efficient frontiers, utilizing matrices in Excel, and so on. We're going to start with our start file, which has a data set of asset prices and returns, and we're going to fill in the following information: calculating a correlation matrix, a covariance matrix, portfolio mean, portfolio standard deviation, and then we'll start building efficient frontiers in portfolios. Learning objective number 1, we're going to compute portfolio mean and volatility using arrays and matrix multiplication. This is a bit of a longer one, but the next ones are a little shorter, I believe. So let's first talk about where we are in the course. In topic 1, we used historical data and models to forecast expected return and standard deviation. And in this topic, we're going to use those asset means and volatilities, or expected returns and volatilities, and start forming portfolios of those assets. So we can say is the tools we used in topic 1 were used to create a data set like this, where I have US equity, foreign equity, emerging market equity, bonds, and money market or cash. And I have a set of expected returns for each asset, volatility. I'm going to first set up an equal weight portfolio of these 5 assets, 20% invested in each. So it's 100% invested. And then what I'm going to do is calculate the portfolio mean and standard deviation of that equal weight portfolio. And then in learning objectives number 2 and 3, we'll start forming optimal portfolios. In other words, creating optimal sets of weights. So the first thing I want to do is go to the spreadsheet, and I want to first fill in the correlation matrix, because to calculate the portfolio volatility, we're going to later need the correlation matrix. So let's go ahead and do that. So I'm going to go to my spreadsheet. You can see we have topic 2, and this is the spreadsheet that we were just looking at. These are my inputs. Remember, this color here means that it is an input cell or values. And if you go to the asset price tab, you can see I have data from 2024 and older for SPY, EFA, EMA, bonds, bills. So that would be my money market. And then I also have calculated returns already from 2024 and back. And the first thing we're going to do is create a correlation matrix. Now, correlations show how 2 assets relate to each other. And in other words, if they move, if you know what happens to stocks in US, say SPY, and they're highly correlated with EFA stocks, you'd say the correlation approaches 1. If they're opposite, it'd be -1. What we want to do is create a matrix of correlations. So I've already set up an area to put it, and that area is going to be this area right here. So these are going to be my correlations. Let's go ahead and do it, and we'll talk about it. So to do this, we're going to go to Data, Data Analysis. And if you don't have the Data Analysis tool here, you want to go to File Options, Add-ins, and add the Data Analysis tool pack. So I'm going to go to Data Analysis. I'm going to select Correlation. And then it asks for an input. This input is a set of asset returns. So I'm going to come over here, and I'm going to select this data, including the labels up there. So that's starting in row 3. I'll go to the bottom of that series, K119. I want to click on here that the label is included in the first row. And the output, I want to put the output at the top of our spreadsheet here. I don't want to put it in a new workbook. And I'm just going to select this corner right here. And for the, that is M4. So I want to take the asset returns from G3 to K119. And G3, or that third row, includes my labels. And I want to put a correlation matrix starting in M4. I'll hit OK. Hit OK to replace that those data labels that are currently there. And what you see now, these are the correlations. So what you see is SPY is perfectly correlated to SPY, EFA is perfectly correlated to itself. So this prime diagonal here is always 1. And then what you see is the off diagonals are showing the correlation matrix values. So SPY and EFA on this, using this data set, has a 0.86 correlation, which is very high. 1 is perfectly correlated. So SPY is 0.86 correlation to EFA, 0.697 correlation to EMA. That's the emerging market stock. EFA or EFA is the developed nation stock minus North America. Has a 0.39 correlation to bonds and 0.11 to bills or money market. So these are my correlations. Notice it doesn't show anything up here because these would be completely redundant. So EFA and SPY would be the same as SPY and EFA. It would just have this value here. What I did is I saved us a whole lot of trouble. I have a link down here which just takes the numbers above. And then what I do is I fill in this off diagonal, this top right off diagonal. And it's just repeating numbers you see on the bottom left values, off diagonals. So this is the entire correlation matrix. Notice the numbers in the orange there, those are the unique values, and the ones up here are just referencing the numbers below. So for example, you see this number here. The correlation between bonds and SPY is the same as between SPY and bonds, so it's just a link. So there's my correlation matrix. I'm going to go back to the topic 2 workbook, and I just want to have a link to those correlations. So I just want to show you how you would create a correlation matrix from the raw data. So I'm going to go to N2 in my topic 2 workbook. I'm going to say equals, then I'll click on my asset prices, select that top correlation value in the correlation matrix, which is N14, hit enter, and then I'm just going to copy down and then copy over. Okay, so this is going to be a building block to calculate portfolio volatility. So now I have my correlations over here. Okay, so we got that done. The first thing I'm going to do is something relatively easy. I'm going to make it look hard, because that's what I do, and that is calculate a portfolio mean, a weighted average return of a portfolio that's invested 20% in each asset. Everyone kind of knows how to do that, but let's go ahead and talk about this. We say the return of a portfolio, we'll call it RP, is the sum from I equal 1 to N. So what is I? I is the asset number. Say you have 3 assets. So I is going to go from 1 to 3 in the case where you have 3 assets, and I just denotes which asset. So the return of a portfolio is the sum from I equal 1 to N, WI, RI. So in other words, if you were to count the number of assets, again, say there's 3 assets, we'll call them assets 1, 2, and 3. This counter, this sum counter, is going to set I equal to 1. When I is equal to 1, you're going to have WI-RI is going to be W1-R1. It's then going to set I equal to 2, and then have W2-R2, and then I equal to 3, and set WI-RI to W3-R3. So the weighted average portfolio return, or the return of the portfolio, is simply a sum of each weight times each return. So the overall formula is going to be this. The weight in 1 times return in 1, weight in 2 times return in 2, and so on. But it's important to use this notation here because we're going to need this later when we do something a little more complicated, and that's when we calculate portfolio volatility or standard deviation. All right, now to do this in Excel, it's pretty simple. We're going to use something called sum product. So when we use a sum product, we just say take all the contents in a particular row times another row, and take the sum of all the products. So for example, if I go to my spreadsheet, notice, by the way, in this spreadsheet, I've given some named some ranges. This range right here is called means. It's the mean returns or expected returns. This column here of portfolio volatilities are called vols, and this vector of weights is called W. So to calculate portfolio return of these 5 assets, I could do it the hard way and say equals or plus this return times this weight plus this return times this weight. And I could just take the sum of all the products. But sum product does that for us in one step. Equals sum product. I'll put in my means, comma, notice it actually gave the name means, and my weights, which is called W, and then hit enter. So the expected return of an equal weight portfolio is simply going to be the product of the weights and returns, and we can just use the sum product formula, and it's 7.5%. So that's how we calculate portfolio mean, or portfolio expected return. Okay, let's talk about how I can do this using matrix algebra. It's not really needed in this case, but it's going to be really helpful in the next case. I don't know how I'd function without matrix algebra. No pun intended saying function. So let's talk about what a matrix is. A matrix is a rectangular array of numbers or items. A matrix is only one row. We're going to call that a row vector. A matrix with only one column, we'll just call it a column vector. Often, when we talk about a matrix, we'll just use a single letter. We'll say matrix A. And when we want to refer to an individual item in matrix A, say matrix A looks like, some rows and columns. If you want to specify any particular item in that matrix, what we're going to do, and Excel uses this, is we're going to use row column identifier. So if this is matrix A, and you want to refer to the first row, first column in matrix A, we say item Aij, where I is the row, J is the column. Aij refers to the value in row I and column J of matrix A. So if I say A11, that's going to be the first row, first column. If I say A12, that would be the first row, that would be the second column. So that's how I'm going to refer to items in matrices in Excel using row column identifier or Aij. Matrix A, column I, row I, column J. Now, we're going to wind up multiplying matrices together to solve some problems. So you can take two matrices and multiply them together. And if you had, say, matrix A, you want to multiply that by matrix B, you would write the new resulting matrix A times B, or simply AB. Now, if the number of columns in A equals the number of rows in B, in other words, it has the same inner dimensions, you can multiply the two matrices. So in other words, if this is the dimensions of A and this is the dimensions of B, it has a certain amount of rows and a certain amount of columns in A and B. You can only multiply matrices together if they have the same inner dimensions. In other words, the columns of the first matrix equal to the number of rows of the second matrix. In other words, I can multiply a 2 by 3, and we'll just write this 2 rows by 3 columns, by a 3 by 5, because it has the same inner dimensions. So you can only multiply matrices that have the same inner dimension. Now the resulting matrix, in this case AB, has the dimensions of the outer. So again, I'll write this example, if I have a 2 by 3 is my A, and a 3 by 5 is my B, so that's my A, and my B has 3 rows by 5 columns. You can multiply them together, they have the same inner dimensions, and the new matrix is going to be a 2 by 5. Okay, so we haven't really talked about what multiplying together means, but I've determined that you can multiply two matrices together if they have the same inner dimensions, and the new matrix that you're creating will have the outer dimensions of the two. So what does it mean to multiply two matrices together? each resulting value in the new matrix, in this case AB, each item in the new matrix is going to be a sum product of the ith row of A times the jth column of B. So in other words, I multiply A times B. And if I want to refer to that new matrix AB, and I want to say, well, what's in row I, column J of AB? Well, it's a sum product of the ith row of A times the jth column of B. So each value is a sum product. All right, and that, you can get an idea why it has to have the same inner dimensions. That's the only way you can do a multiplication, kind of a sum product, if it has the same dimensions. Excel uses the function mmult, built-in function, and you just specify matrix A and matrix B. Say we'll call it matrix 1 and matrix 2. And to enter the matrix formula into Excel, you can't just enter the formula and hit enter. You have to enter the formula and hit Control-Shift-Enter. All right, well, that's a lot. So what are we doing with all this? Well, I want to calculate portfolio mean return using matrix algebra. And this is really just to give you an idea of how matrix algebra works, because I can really just use sum product, but I really need this tool to calculate portfolio volatility in a few minutes. So we could calculate the portfolio mean. Remember, the portfolio mean is just going to be these sets of returns, mean returns, times this vector of weights. So I know how to do a sum product. We already did that. But let's use matrix algebra to do it. Let's use matrix algebra to say, let's call this R, and let's call this W. Okay, we'll call this vector R, and we'll call this vector W using just single letters. I can calculate the portfolio mean by taking the transpose of W. I'll write that WT. What is WT? Well, it just takes these weights and makes it a row vector instead of a column. So I could say the portfolio mean is going to be a transpose of a column vector of weights times the column vector of returns. Now, why the heck do I have to transpose it? Because if you take this example here, these are two column vectors. They both have dimensions, both these returns and these weights, of 5 rows, 1 column. 5 rows by 1 column. I can't multiply a 1 by 5 times a 1 by 5. They don't have the same inner dimensions. The sum products won't work, in other words. What I need to do is convert one of them to a 5 by 1. I do that by transposing. So, get back to here. I am going to transpose those weights of W into a row vector. That will create a 1 by 5. R, I said, is going to be a 5 by 1. They have the same inner dimensions. In other words, the sum products are going to work. The resulting matrix is going to be a 1 by 1, the outer dimensions, which is a 1 row by 1 column. It's a single value. So let's do that in Excel. I'm going to go to the spreadsheet, and instead of using sum product, I'll say equals mmult. I'm going to take my weights right here. Whoops. My equals mmult. These are my weights, but I want to actually transpose, which is another Excel function, transpose W. It's going to turn those weights into a row vector times the returns. So this is transpose W. That's going to be a 1 by 5. and this is a 5 by 1. Control Shift Enter. There's my 7.5%. So this resulting matrix here is a 1 by 1. In other words, it's just a single value, and that's my 7.5% I saw before. So that is matrix algebra. The resulting value in the new matrix is the ith row of A times the jth column of B. And so it's the sum product of the 5 values, the products of the 5 returns and weights. Okay, well, that was painful, and in the end, I usually just use sum product, but I need to give you those tools because we need to talk about calculating portfolio standard deviation. All right, so far I have portfolio mean. It's just going to be W transpose R, or in this case, M volt transpose of W, comma means. Now I need to calculate portfolio standard deviation. I cannot just take a transpose of weights times standard deviations. I cannot. The standard deviation of portfolio is not the simple weighted average, because if these assets are not perfectly correlated, it's something lower than that because of the diversification effect between the assets. So that opens up a whole can of worms. And so let's talk about how we calculate portfolio volatility, or we'll just call it sigma p. All right, portfolio standard deviation is very complicated. The portfolio standard deviation or volatility is less than the weighted average because of diversification benefits when you combine not perfectly correlated assets. And here's the formula for portfolio variance. Again, I want to warn you, when I say portfolio volatility, I mean portfolio standard deviation. In finance, we use the word standard deviation and volatility to mean the same thing. So this is portfolio variance, sigma squared. To calculate the portfolio variance, it's the sum of I and J. Ooh, there's 2 variables now. From equals to 1 to n, where n is the number of assets. And then here's the formula. So Wi, Wj, sigma ij. Now in statistics, if you see sigma and then you have 2 subscripts, say in this case I and j, that refers to covariance terms. All right, so it's when you see if sigma, if I is 1 and j is 2, and that would be sigma 1, 2, that means the covariance between 1 and 2. Covariance is a measure of how assets co-vary, how they move together and apart. It's similar to correlation, but it's a little bit different. So, how do I use this formula? There are 2 counters in this case to calculate the product, or the sum of these product. And those 2 counters are I and j. So you can think about this. And if there's only 3 assets, so n is equal to 3, we said I and j equal to 1. Plug and chug the formula. W1, Wj, sigma 1, 1. I'm sorry, W1, W1, sigma 1, 1. Set I equal 2 and j equal to, I equal to 2 and j equal to 1. And plug and chug my formula. W2, W1, sigma 1, 2. Said I equal to 3 and keep j equal to 1. So when you apply this formula, I and j equal 1 to n, what it's doing is it's accounting for all of the pairwise combinations of those assets. So when you have 3 assets, there are 9 pairwise combinations. 1 with 1, or 1 with 1, 1 with 2, 1 with 3, 2 with 1, 2 with 2, 2 with 3, 3 with 1, 3 with 2, 3 with 3. 9 pairwise combinations. In order to get the portfolio variance, we need to account for how all these assets co-vary. So notice what we're going to do is we're going to just simple plug and chug, calculate all these values, these 9 values, add them together, and that's the portfolio variance. We take the square root of that, and that's portfolio standard deviation. All right. let's talk about the covariance matrix. Just like you have a correlation matrix that looks maybe like this, correlation between 1 and 1, 2 and 1, 3 and 1, and so on. We've calculated one of those. You could also have a covariance matrix, which shows all the covariance terms. Covariance between 1 with 1, 2 with 1, 3 with 1, and so on. By definition, the covariance between any two assets, say I and J, depends on this. Their correlations, say correlation IJ, and the two standard deviations. So let's take this case right here. What is the covariance between asset 2 and asset 1? It is the correlation between asset 2 and asset 1 times the standard deviation of asset 2 times the standard deviation of asset 1. What is the covariance between 3 and 1? Well, it's the correlation between the two times the product of the two standard deviations. What is 1 with 1? Well, it's the correlation between 1 and 1 times the standard deviation of 1 times the standard deviation 1. Oh, by the way, the correlation between 1 and 1 is 1. And you can just rewrite this as sigma 1 squared. This is really just the variance of 1. So actually these fall away because they're 1s, and these are just variance terms. So sometimes this is called the covariance variance matrix, or the variance covariance matrix, because these are actually just variance terms. It's the variance of 1, the variance of 2, and variance of 3. These are actually the covariance terms, the off diagonals. So this is pretty complicated. To calculate the portfolio variance, I need to know all of the covariance terms. That's what we got from the last slide. And then what we need to do is have each correlation times the standard deviations. Okay, here's how we're going to do this in our spreadsheet. Ideally, we want to create a matrix, that looks like this, that combines all the correlations and the standard deviation terms and calculates our covariance matrix. How we're going to do it in Excel is we're going to multiply a column of volatilities times a row of volatilities and multiply times the correlations. So notice how I have 3 terms in here, because this number here is going to be a product of 3 numbers. And this number here, again, is going to be a product of 3 numbers. So here's how we're going to do it in Excel. This is a little complicated or confusing, but you're going to love it after a while. It's going to save you a lot of time. I'm not going to use mmult, because notice this new matrix here, this covariance matrix, this number isn't a sum product. It isn't an entire row times an entire column. It's really just multiplying 3 matrix points together. It's not a whole row times a whole column and so on. So in Excel, if you want to do something like that, what we're going to do is we're going to come down here to create, again, our goal here is to create a covariance matrix. Now I could do it the really hard way, which is I would take this correlation times this standard deviation times this standard deviation, and I have to do each one of them. So US equities and foreign equities, this correlation times the standard deviation of US times the standard deviation of foreign equity. I'd have to do each term like that. But in Excel, there's a neat little way we can do this. I'm going to select this entire array or matrix, and I'm going to say equals vols, that's just the column vector standard deviations, times transpose vols times correl, my correlation matrix. Notice all this is selected. I'm going to enter this formula across the entire, what we say is array or matrix, by hitting Control-Shift-Enter. Remember those two numbers, 225 and 195? These are now covariance terms. Again, this is not mmult. This is just, it's confusing. This is just multiplying arrays or matrices in Excel, but each one is not a sum product. Each one is just multiplying the corresponding value. So example, let me just go back to the spreadsheet here. To calculate this value here, I just need to multiply the first vol times the second vol. So this is the covariance between the first and second assets. So I need to multiply these two times this correlation matrix point. They need to come together and create this number here. When I do this vols times transpose times vols times Corel, it is just simply taking the corresponding points from each one of the matrices, not doing a sum product. Okay, so there we go. We have our covariance matrix. If you make a mistake, sometimes you have to highlight the entire area, delete it, and then add the formula. Remember, when I entered that formula, I selected all area first. I put in this formula, and then I hit Control-Shift-Enter. Holding the Control, holding the Shift, and then hitting Enter. All right, so let's go back to what we're trying to do here. I have a couple more things, and then we're going to calculate portfolio variance and standard deviation. I created a covariance matrix. Now, be careful. When you create a covariance matrix, they have a time interval. In other words, if this data, if these volatilities are annualized, and they are, the corresponding covariance matrix, they will be annualized covariance terms also. Now, correlations, these are based on monthly data, but we wouldn't say it's a monthly correlation. Correlation has no time component. It's just a relationship. When one goes up, does the other one tend to go in the same direction? Yes. Well, that doesn't matter if it's daily, weekly, minute, or annual. So what determines whether that covariance matrix is monthly, annual, or so on is whatever the term or the frequency of the standard deviation. I'm going to define these as annualized volatilities or standard deviations. So this is an annualized covariance matrix, which allows us later to calculate a annualized portfolio standard deviation. Okay. Now, last step, hardest step. I need to calculate portfolio standard deviation. Now, the variance of my portfolio, my sigma squared, is going to be the sum of Wi, Wj, sigma ij. I told you that before. We now have all the covariance terms. Now we just need to do a last step to calculate the portfolio variance. And what I'm doing here is something I talked about before, is when I want to calculate portfolio variance, I need to calculate the double sum from I and j equal to 1 to n of Wi, Wj, sigma ij. Now what that means is I want to calculate the portfolio standard deviation using the vector, the vector of weights, that's the W's, and the covariance matrix. How we do that in Excel is we're going to use a matrix formula, a matrix multiplication formula. And what we're going to do to create this portfolio standard deviation. Now, portfolio standard deviation is one value. It's a 1 by 1 vector or matrix. One row, one column. How do I get that? Well, I'm actually going to take a row of weights, 1 by n, times the covariance matrix. Now, the covariance matrix is square, so we'll say it's at n by n. I'm allowed to multiply a row vector of weights times a covariance matrix because they have the same inner dimensions, and the new resulting matrix is a 1 by n. Once I do that, now what that does, it combines the weights and the covariance terms one time. Then I need to put the other corresponding weight. So what I do is I then multiply that multiplication times a column vector of weights. Remember I said when you do the first matrix multiplication, this times this, you get a 1 by n, and then you multiply times this n by 1, my weights column, and I wind up with a 1 by 1. And what it does, it counts for all the combinations of the covariances and the weights. In Excel, how we're going to do it is we're going to write a formula where I do the first m mult inside of these brackets. I'm going to do an m mult of the transpose of the weights times the covariance matrix. Covariance matrix I'm going to call S. Column vector of weights I'm going to call W. And then my that resulting matrix is then going to be multiplied again using another matrix multiplication times the W's. I'll take all that to the 1/2 power to give me a standard deviation. So to the spreadsheet. Notice I have a range name here. This is S for the covariance matrix. This is W. So here we're going to type in portfolio standard deviation formula. Equals m mult, bracket, m mult, transpose, W, S, W to the 1/2 power. That inner m mult does the first W times S, and then that outer m mult takes that resulting matrix and multiplies times W column one more time. Control Shift Enter. The portfolio standard deviation is 9.44 for an equal weight portfolio. And by the way, I had to do the Control Shift Enter to do that formula. So that's it. That's portfolio standard deviation. So in the next topic, we're going to start constructing optimal portfolios. Sorry for all the pain, but we needed it.